In this video, we're going to go over the heat of vaporization and heat of fusion. The heat of fusion, or delta H of fusion, is the amount of energy required to melt a solid at its melting point. Remove the same energy to freeze a liquid. So the amount of energy required to melt a solid at its melting point, if you remove the same amount of energy, it's equal to the energy released to freeze the liquid. Heat of vaporization, or delta H of vaporization, is the amount of energy required to boil a liquid at its boiling point. If you remove the same amount of energy, that's the energy to condense a gas. The delta H of vaporization, so the heat of fusion or heat of vaporization, is usually much greater than the heat of fusion because all intermolecular forces of attraction must be disrupted to enter the gas phase, while only some of the intermolecular forces of attraction have to be disrupted to get from solid to liquid. This is examples of heat of fusion and heat of vaporization. So for aluminum, the heat of fusion is 158 calories per gram, and the heat of vaporization is 96 calories per gram. The ethanol heat of fusion is 26 calories per gram, while the heat of vaporization is 206 calories per gram. And so you can see there's a lot more energy to the delta H of vaporization is a lot higher than that of fusion. Same with water. Water is 79.5 for heat of fusion, and the heat of vaporization is 539 calories per gram. So applications of heat of vaporization, evaporative cooling. So evaporation is changing from liquid to gas phase below the boiling point. It's endothermic and requires the heat of vaporization. Evaporation cools your skin when you step out of the shower because it absorbs the heat energy from your skin. So when you take a shower and you step out of the shower, you start to feel cold. And this is because the water on your body undergoes an endothermic change of state called evaporation. It absorbs the heat energy from your skin and makes you colder. Sweating is also a form of evaporative cooling. It's an exothermic phase changes, add heat to the steam, and then when you have exothermic phase changes, you add heat to the body, and this results in steam burns. So steam burns are like the opposite, and you have exothermic phase changes. So for sweating, to go back to sweating, sweating is the body's natural cooling system. So you have cold air, you have the water on your skin going through from your sweat gland. You have air coming from outside of your body, and it evaporates that sweat, causing you to feel cooler. In summary, the heat of vaporization is the amount of heat per gram that is required for vaporization of a liquid at its boiling point or removed from a gas during condensation. The heat of fusion is the amount of heat per gram required for melting a solid at its boiling or melting point or removed from the liquid during freezing. Evaporation causes the surroundings to become cooler, called evaporative cooling, because it is an endothermic process. Condensation is an exothermic process releasing heat to the surroundings.